Welcome back. Now in nuclear chemistry, let's look at two types of decay that are common. So in radioactive decay, you hear that term a lot. What it means is you have a nuclide, which we have right here, an isotope, breaking down. So we have polonium-218. This is the mass. Whenever they do the hyphen and they show the mass, sometimes I have students come up and they ask me how they would know what this number is. If it's not the atomic number, then it has to be the mass. And that's an isotope, which is why it doesn't match the periodic table. So this is polonium-218. So we put the mass here. We look at a periodic table, and we find that the protons are 84. If it weren't 84, would it be polonium? So this will always match your symbol. So you use the symbol to rewrite it like this in order to do your equation for alpha decay. So when you're doing nuclear equations, you have to rewrite it in this form so that we can watch both the protons, remember the protons are here, and the mass, and we can see what's changing. So this one wants, enter the equation, my abbreviation for equation is EQN. For alpha decay, remember that an alpha particle, we could also write alpha there, is really just a helium nucleus. So here's the mass, here's the protons, and these are being subtracted because they're being given off. So it's emitting this alpha nucleus. And if we look at a periodic table, then this is going from 84 to 82. And if we look at a periodic table and find what 82 is, we are going to find that it's lead. And then the only other thing that's changed is we've lost 4 from our mass. So we take this away from the 218. And our mass is 214 lead. And then 82 represents, always, the protons that go with lead. So you need a periodic table in order to do these, unless you know the periodic table by heart. The next one we want you to do is beta decay of lead-211. So again, this hyphen, 211, means that this is the mass of your isotope. They're giving you that because we know it can't be the protons because they've given that here, and they only either do mass or protons. That's what you see. Since they gave you the symbol, they know that you can find the protons. So I've rewritten it here. Here you have your mass. Here you have your protons. And now we're doing beta decay, and this is why you have to remember what a beta particle looks like. So we say that it's a high-speed electron. We say it has 0 mass. It's not necessarily true, but it's so small. We consider it no mass. And then we have to do this. When you take 82 and you minus -1, this kind of throws students because you're subtracting every time you give one off, it goes up to 83. So our new proton count is 83, and that should match bismuth. But our mass, because it was 0, did not change. So it's still 211. So the mass does not change with the beta decay or the positron emission, but we did have to subtract a -1, and so we went up. And in nuclear reactions, that's when you actually do change the nucleus, hence the name. It's the only time. Thankfully, they're very, very rare, these nuclear reactions. But they are important to know, again, for nursing because many of the tools that you use, X-rays, MRIs, CT scans, PET scans, they use nuclear chemistry.